Okay, functions and their properties. So let's start, first of all, with some examples of what we consider functions. Okay, these are all functions that you've seen before. The first one, g of x is equal to x plus 3. Can anybody tell me the name of that type of function? What do we call it? X plus 3 kind of equation is that? Anybody? Starts with an L. Linear. All right, so that's a linear function. Mx plus b, coming back to you. I know it's been a little while since we've done the math. Y equals x squared plus 1. What's that name? Quadratic. When the x is squared, it's a quadratic equation. We've got y equals the square root of x minus 2. We could go with two different names here. The general name would be radical. Okay, any kind of root, square root, cube root, fourth root, etc. Radical, or you could call it a square root function. That one's pretty easy. You got to say it to say the function. And then the last one there should be somewhat familiar. F of x is equal to the absolute value of x. So obviously that's an absolute value function. You may or may not be familiar with its graph and things of that sort. We'll talk about it a little bit more in this class than we had in the past. So you should be familiar with linear, quadratic, and radical from Math 1 and Math 2. I just used some different notation there. The first one's g of x. You could just have y equals. You could have f of x. Any of those names mean the same thing. Just the g of x and the f of x are what we consider function notation. Y equals is more of a general notation. So let's start with the definition of a function. Okay, a definition, it's not the only definition of a function, but a definition of a function is a relation in which each element of the domain is paired with only one element of the range. So only one being the key here. Now, a simpler way of saying that is that for every x, there is only one y. Now, that probably makes a little bit more sense to you, or that may be something that you're a little bit more familiar with up to this point. But you do need to be familiar with using these terms domain and range. Okay, domain and range. You need to be familiar with that idea. They will use that terminology throughout this course. So when you see domain, you should think x values. When you see range, you should think y values. So nothing really truly new, I don't think, up to this point. Just a little bit of review, recap. So every element of the domain, aka your x values, paired with only one element of the range. Every x has only one y. So let's look at some different forms of how this may be expressed to you. The first one, we've seen the definition. Now let's look at some visual representations here. We can have some mapping of our functions. So here, the f of x equals the absolute value of x function has been mapped, and g of x is equal to x plus 3 function has been mapped. So what the mapping does, and you may have, hopefully you've seen these before, you may not have, but you've got your x values here on the left, you've got your y values in the oval on the right. So what it does is it says, okay, if my x value is -3, what when I plug -3 into my function, the absolute value of -3 is +3. So -3 maps to +3 for this function. Okay, -2, the absolute value of -2 is +2, so -2 maps to +2 for this function. So forth and so on. Now, with this function, notice +1 also maps to +1. But it's still a function because every x has only one line. Every x has only one line coming out of it. It's okay that the y values have multiple x values. You're only concerned about your x values having one single line coming out of it, mapping to one single y value. We'll talk about the reverse later on. G of x is equal to x plus 3. Okay, plug in 0. 0 plus 3 is 0. Or excuse me, 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. So forth and so on. So this one looks a little bit better than the other one because the y values only have one x. But again, we're only concerned about each x having only one line. All right, so those are some mappings. Similar to a mapping, we can have tables. Okay, we can represent a function using tables. So I did the other two functions here. The quadratic function, x squared plus 1, the square root function, square root of x minus 2. So I just came up with a small table of values. This is not the complete table of values. I just picked -3 to 3 is typically what I use. But it depends on the data. Plug in the x value, you get the y value out. Now, with the square root function, something interesting happens. I don't start with -3. Because if I plug -3 into my function, -3 minus 2 is -5. Are we allowed to take the square root of negative numbers? No, you cannot take the square root of a negative number. You can only take the square root of positive numbers and 0. So I didn't start with -3. I went ahead and I went down to 0. Now 0 still doesn't work because 0 minus 2 is -2. The square root of -2 does not exist. So I wrote out the word undefined here beside 0. 1 is still undefined. 1 minus 2 is -1. Square root of -1 is not defined. It is I, if you did it in the imaginary universe in Math 2. We'll talk about it a little bit more in Math 3. But I use the abbreviation for undefined there. Okay, so UND means undefined, or I guess technically you could use DNE for does not exist. I prefer undefined though. Okay. But finally, when we get to positive 2, 2 minus 2 is 0, the square root of 0 is 0, so now our function is defined, and we can continue to put, we get our y values, we get a range here. For 4, I used the square root of 2. For 8, I found the decimal approximation for the square root of 6. I was just mixing it up there. Just to show you, the answers aren't always whole numbers. Another thing, just kind of random point that I want to throw in here. We're in a very bad habit, well, it's not bad habit, but we're just in the habit of always using whole numbers for our x values. But remember, you're not limited to that, okay? I could plug 1.5 into this function. I could square 1.5 and I could add 1 to it. It just doesn't give me a nice whole number answer. So that's why we kind of shy away from those. I could plug 5 halves into the square root of x minus 2 and I would get an answer. But again, it just doesn't give me a nice, pretty whole number answer. So that's why we don't typically include it in our tables, but that doesn't mean that we can't. Okay, so just a little side note there. All right, so we've got mappings, we've got tables. Here's what I want you to do. I want you to, with the people around you, split up these 4 functions, and I want you to graph them let's just use what's in the table or what's on the map, okay? Just use the information in the tables or the information on the